Good afternoon, everyone. Many thanks for taking some time out of your day to come to our presentation today, presented by the Chartered Institute of Civil Engineering Surveyors for Ireland and Northern Ireland. Draiochta Lundberg from Apex Surveys is kindly offered to the benefits of using laser scanning in topo surveys. Draiochta, he came out of TU Dublin, as it's known now, in 2001. His background is in geosurveying, and then later on he pursued a degree in mineral surveying and resource management at the University of Glamorgan, and has worked in the likes of the Tara mines, one of the largest zinc mine sites in Europe, and also on the Dublin Port Tunnel as part of the Northern Surface Works, and had some involvement in the 2016 Olympic Games for setting out the stadiums there in Rio, in Brazil. And more recently, he's been working with Apex Surveys, starting out as a surveyor and progressing through to client manager. In terms of the institution ourselves, we're looking for committee members to get involved. So if anyone out there is passionate about the profession and would like to do more, you can reach out there and contact us via the QR code there below. But many thanks to everyone, and I'll hand it over to Draiochta.
Great. Just let me try and share my screen. Bear with me 1 second. Share. Which screen? Is it share my screen yet, Ron?
Just go into presenter mode there. Yeah, we can see your PowerPoint. Just go into presenter mode.
But I want to
slideshow.
Share the screen on the right, because I'm going to, when I go full screen, you won't see that. Bear with me a second.
Sure, no problem.
Sorry. You can see my cover slide here along with the next page.
Yeah.
I need to flick it over to the other. Apologies. I know I did this the other day.
Yeah, no problem.
Show your. Oh, here we go. Okay. Is that correct now? Can you just see the cover? You don't see my notes?
See yourself. There we go. Now you have it.
It's
there we go. Perfect.
It's how it should.
Okay. Apologies. Sorry, a little technical issue there. Okay, so thanks for that, Ronan. Let me just tell you a little bit about ourselves, Apex Surveys. We are established in 1990. We're working nationwide, a wide range of sectors and environments. We've 5 kind of core departments: land surveying, utility mapping, laser scanning, photogrammetry, and drone surveys. And we have a host of chartered surveyors working at the company. At Apex Surveys, we try, we're committed to using the latest and best technology and techniques. One way that we achieve that is through the laser scanning surveys, and using point cloud laser scanning technology for topo surveys allows us to deliver highly accurate data to our clients. In this talk, I'll try to explain exactly how point cloud laser scanning work and what advantages they have over other topo survey methods. Okay, so just traditionally land surveying, you've got, total station, hard surfaces, some kind of drawbacks to that. It's quite slow to collect the data. You may need traffic management, getting reflective measurements off the road when cars are flying by is very difficult. So it's kind of not as good as the scanner. We use GPS for soft detail, great when you're in an open field, but very limited coverage if you're in a ditch with a tree canopy or if you go in close to buildings. Whereas the laser scanner, it's a rapid setup, ease of use. You can eliminate the need for traffic management, a very good accuracy with the scanner as well. It's kind of picking up around 1 million points per second. So many industry professionals are aware of how important laser scanning surveys are. in a variety of sectors. However, few people outside of topo survey professionals actually understand what these are and how they work. Put simply, the point cloud is a collection of 3D data points that have been measured and recorded to a very high accuracy. The laser scanner spins around with up to 1 million measurements taken per second. And once this raw data has been collected, an experienced topo surveyor can then compile the scans together into a registered point cloud, which can be used for measuring and modeling. Here, we are able to survey the rails from the safety of behind the yellow line at the platform. And in Ireland, the standard rail gauge is 1600 millimeters. I took that measurement just on a one-off, and it's, you know, accurate to a millimeter. So no need to get track safety coordinator. That over here, it can take weeks in advance. You need to book it. No need to undergo the special personal track safety training course, and some of the benefits of using the scanner there. In terms of putting those scans together, I'll just give you an example. That's 2 scan worlds in blue and orange, which the scanner just didn't quite align them when they first connected. So before the point cloud can be constructed, we have to align them. So I would have gone from the corner of a building, used the pillars along the wall to make sure that everything's lining up in the x-axis, shift and then rotate to the hard detail. The scanner itself, the technology, it produces a light waver laser which reflects off surfaces and back to the sensor. The sensor can calculate the distance between itself and the surface by measuring the time taken for the light wave to return. Those same scans came in off on height as well, so I had to shift them down so they tie in. The laser scanner is moved around the site so that the surfaces of the structure buildings can be viewed and scanned from all sides. The scan worlds created from each scan position are joined together in a process known as registration, and that creates a much larger point cloud. Just when it comes to registration, you have your target set up over a control point and note the height, and then use your coordinates, which would have been observed with GPS or known coordinates. They get added into the control space, and then the whole point cloud can be coordinated. The scan data can be colored using imagery from a camera that's built into the scanner. The RTC scanner gives excellent imagery. P-series will kind of artificially color it using red, green and blue, but sometimes that's a bit bleached out. So there's a iStar camera that you can put in the place where the scanner was, and it's going to record HD images. The point cloud that you're looking at here has a combination of iStar for the external imagery, and then when we go inside in a moment, you'll see imagery taken from the scanner itself through the camera. This hospital, we were asked to survey, there was a mental health ward, infectious diseases. So the architects who are looking to do the remodeling, it's very difficult to get access. So by sharing the point cloud, they're able to inspect, you know, have a look around any of the rooms that maybe be difficult to get access to usually, and they can take any measurements or inspections without the need to go to site. You may have noticed at the beginning of that you couldn't really see any of the roof. So from the ground with a high parapet, we couldn't see roof detail. The client insists that this was a key component of the survey. So we went back with the drone and we were able to produce a point cloud and an ortho image. And from that, we were able to draw up, like there's very high detail there on the drone. You can see the numbers on the parking spaces, and then all that detail on the roof that isn't visible or safely accessible from the ground was able to be added onto the drawings and then modeled. So this is just a quick look. So after the point cloud has been created, it can be fed into BIM software to provide a full digitized representation of the building or site. This can aid the designers for renovations or proposed changes. And this is an example of a model that we did for the hospital using the data that you looked at previously. It's a very old historical building, a lot of kind of false ceilings there, big voids. So interesting job for the scanner. What are the benefits of laser scanning surveys? Laser scanning has been around since the late 90s. Measurements are highly accurate, allowing for a surveyor to create detailed drawings and models. You can capture millions of points per setup, which is a huge time saving in the field. The scanner can operate in low light or darkness. So rail tunnels, mines, confined spaces, heritage, and allows for 3D visualizations of existing structures, which is a great benefit in heritage surveys. The cloud can be shared with different teams, avoiding unnecessary visits to the site. So this was a monument down in the south of Ireland. The heritage architect asked us to prepare a point cloud so they could do their conditioning on it. Buildings or structures with complicated designs also benefit greatly from laser scan surveys. The amount of data on this type of topo survey allows for small details and complexities to be recorded that may not be possible with other methods. An example of this can be seen where laser scanning revealed the full irregularities of the historic structure. So there's a lot of detail there picked up, which with a total station, you'd be there forever. Also, in terms of quality assurance, you can bring the cloud in to CAD, check against your line work, make sure that everything has been drawn accurately. We've used laser scanning to survey many sites and structures, including hospital helipads, airports, bridges, culverts, oil and gas storage tanks. This particular gas tank, there was a risk with confined space entry, so we just lowered the scanner down, reversing the extendable tripod, and we were able to get the measurements inside, millimeter accuracy, the precision of the deformities for the client. Railways, we've used laser scanner a lot. Like railway, you've limited time on the track. Sometimes you have to go on the track. So scanning, you just capture as much as possible in a short period of time. Historic buildings, monuments, silos, quarries, stockpiles, lift shafts, even manholes, motorways. And then in terms of complex structures, I'm going to just go into a little bit more detail here. So this was a water treatment plant that there was issues with the roof, leaking roof, and they didn't want to get multiple people down on site. So with our survey, we were able to pass on the point cloud and they're able to see where the damage was without the need to hire a MUP or risk going up on a ladder. And also, like, this particular site was very remote, so getting someone down there to give access could be an issue as well. From that same data set, we're able to produce 2D, 3D CAD drawings, cross sections. That was the cloud that was used to produce that topo, and then the same cloud also produced roof plan, elevations, floor plans, reflective ceiling plans. And then we went on to do BIM modeling as well. Similar to the hospital, with the high roof, you couldn't see it from the ground, so we used a drone to kind of fill in the gaps. This water treatment plant here, the client wanted a utility survey of all, and then that added into the BIM. So there was a lot of detail there in the plant room, took a while to kind of model it, but again, you know, with open tanks, there's a risk there. The safety of the laser scanner and then being able to pick everything up, it was a great value to the client. We were out in one afternoon and we were able to capture all the information that they wanted for the upgrade. This here is a substation. So our client was looking to put in a new bay at the substation. They need very precise measurements of all the instruments that were there, all the cables, the distance between where the cables touch the ground, for very high precision design work. So we generated this BIM model for them, and they were able to install without ever actually needing to go to site. They were able to get the new design done. And this here is the scan data from that same project. So there's, you know, only a minimal number of scans required. They had cordoned off a safe workspace for us with cones and rope, and we didn't have to worry about non-conductive equipment. You know, there was no risk, and we got the highest amount of detail from minimum setups. Here, a boiler room at a hospital, you know, very high detail was required by the client, so captured everything and then able to produce all the fittings on the wall. With laser scanning for surveying, just what are some of the barriers to entry? The cost of the equipment. Mobile mappers can be hundreds of thousands of euro. Same the likes of the Lundberg. Even, you know, a decent scanner could cost maybe 4 times that of a total station. So there is a kind of a high entry point. There's also a lot of specialized software, you know, to depend on what you want to use. Every manufacturer has their own software. And then there's a kind of, I know surveyors, you know, very good surveyors who just never worked with scanners before. So there's a certain amount of training and upskilling that's required so that they be able to process the data and then extract the information for the data. I think the last kind of barrier of entry is the demand. You know, you need kind of large projects, national bodies, semi-state bodies, city councils, county councils, like big, large scale infrastructure projects for the investment in the likes of a mobile mapper or an Lundberg. If anyone has any questions, I'd be happy to run through those now. Thought I'd keep it nice and quick because it's a lunch break. Any questions there in the chat?
Thanks, Draiochta, for that presentation. I think it was really interesting. Certainly kind of looking at the ESB, they can sort of really see the benefits of the kind of deliverable from, you know, health and safety and future planning. You know, where you can have a full 3D BIM model there. Later on, like if there's any other plant and equipment that needs to go into that particular site again, you know, at least they do have that BIM model available, which is great to see. Then in terms of the, like say, the hospital site there, which you showcased, have you had any kind of challenges with regard to you know, going operational and using drones?
Well, as it happens, that hospital is quite close to a prison. So to get permissions to use the drone, we had to contact the prison services, let them know that it was on behalf of the hospital, because previously we'd been asked to do a road in the area and we were refused. But because it was for the hospital, they gave permission. But, you know, whenever we're using the drone, everything has to go through the IAA, but there's a restricted airspace there at that particular site. So yeah, that was one of the issues that took place with the drone there.
No, good stuff. Anyone else have any questions?
Can't see anything in the chat, I think.
Right. If nobody's any
Wait,
further questions, what else?
I think there are questions here, Ronan.
They're typing, yeah.
Been sent as a question. I thought they'd be in the chat. So sorry, there's a few questions here. Apologies.
Oh, great.
Alison was asking, how do you control the difference in accuracy between the scan and the drone when extracting details for 3D plans and models? The data from the ground, the high precision control network that's there, that's kind of millimeter accurate. The data that you get from the drone, even with ground control, can be sometimes, you know, plus or minus 30 mil. So we bring the point cloud from the drone into the same software where we process the terrestrial data, and then we join it in to make sure that it aligns right. But if you just went out with the drone and created a point cloud, you know, from photography, the levels could vary, you know, plus or minus 30 mil, let's say. Jonathan's asked, which software do you use to digitize the point cloud into a topo survey? Do you have the ability to share the point cloud data for clients to view? So there's a number of different programs on the market, Jonathan. We have special survey software that we use. Everything runs through it to create the survey model. But generally, you can output the point cloud as in a vendor neutral format, which is E57. That E57 file will work. It's kind of similar to a DXF and AutoCAD. It'll work with Bentley MicroStation. It'll work with AutoCAD. And then there's software like CloudWorks from Autodesk, where you can bring the scan data into CAD. You know, there's also in Revit, you have Recap. There's so many different ways. Like, we have different clients, engineers, architects. Everyone's using their own programs of preference. Generally, I would offer for the clients a copy of the cloud in the Leica Geosystems format, because there's a free viewer that Leica have called TrueView, and that earlier on when I showed kind of the measurement taken on the rail track, that was done in that. So it's a very simple package to use, designed for anyone. But in terms of actually getting the most out and extracting it, it can be quite expensive to get into the software. Anne has asked, typically, how long would it take from survey to process the data? It'd depend on the number, like the size of the project, if it was just a small house or a larger site. But kind of as a rule of thumb, I'd say approximately half the time that you're in the field, you should set aside for making sure that you combine those scans accurately and you're able to register them to get the point cloud. Now, depending on what output the client's looking for, if they want a BIM model, you know, it takes a long time to produce that, or if they're looking for elevations, floor plans. So in terms of processing the output drawings and that, it would really depend on the size of the project. But we aim, within a week of being on site, we want to have that scan data registered, and then with our processors, and in kind of 2 to 3 weeks, be looking to get deliverables back to clients. Right, to the next question. Brian. Oh, I missed that last. Are you automating drafting yet? I have reservations about the AI, machine learning, and the rest of it. I just don't have full confidence in it. I know there's some great software packages out there, but we do everything manually by hand. is it just Richard asked, is it just photogrammetry UAV work or LiDAR mounted on the drone that you're using? So previously for drone, it was photogrammetry, but we have acquired a LiDAR drone now as well. And there have been projects where we had LiDAR done for us where we needed it. Andy asked, how are you managing large data sets? Generally, the surveyors will split their files on a daily basis, and we kind of label them. Files from day one would be A, from day two would be B, and so on. And we try and bring them in piecemeal and combine them. Sometimes, you know, you could have 20 kilometers of road, for example. It can just get too big to work with. So there can be a value in chopping up the cloud into sections and just having it done, you know, a kilometer stretch or 2 kilometer stretch at a time. But generally, those large point clouds, we'd save them on the server, and then we always keep the original kind of the registration files. And then after, you know, a couple of years, we'll just free up that local directory where we're working from. Peter has asked, if survey on the ground takes, say, 1 day, how would the modeling take? I think I might have asked that already, but it would depend on what the deliverables are, Peter. I'd say to get your point cloud right and have it there ready to work, you know, roughly half a day. And then depending on what needs to be drafted, you know, a couple of days, elevations, floor plans, it really depends on what's needed. Brett has asked, what software are you using for creating the topo drawings from the point clouds? So we do have a special survey software that we're using from Atlas called SCC, but what a lot of people would be using, the likes of Recap or CloudWorks. It's quite popular bringing that into the Autodesk family. Kirk asked, what would you estimate it as the processing time compared to on-site? Approximately half for registration, but sometimes triple or quadruple for drafting and modeling, depending on what the output is. Mika asked, what would be the best way to clean the point cloud? Cleaning the point cloud is, if you have experience with it, it can be a real pain. You can go into each individual scan world and clean them one by one. There are ways that you can actually ask the software to detect things that are moving, which generally would be reflections or cars driving by, and to try and delete them all as one. But unfortunately, the best way to clean is just to open up the individual model space of the scan world and delete what you don't want. Alison asked if we're using an AI offering to extract line work. No, we have not been doing that. Joseph, what issues do you run into in terms of storage? How long do you usually wait to delete the point cloud? It's been used for its purpose. Storage is an issue. We're forever adding to the servers. We tend to run 2 side by side, and it'll generally fill up in less than 6 months. So we have a kind of, in case a client has any queries or we want to revisit something, we can look at it then and there. But everything gets archived, you know, maybe after 5 years, we might consider letting something go, but we hold on to all the data. So we'd be deleting it from the local access, but it would be stored on the servers. How long did it take to model the substation, for example? Adam Ball asks. I think that substation took about a week to model. A lot of kind of intricate elements and families that had to be created. You know, it wasn't generic door, window families. So it was quite a tricky one. Xavier asked, what measures were placed in the hospital project to assure accuracy? Black and white targets, spheres, any checkpoints? Was the project geo-referenced? So we had a control network outside of the building, and then we were connecting out to that. We would also use black and white targets on the likes of corridors or stairwells. It can be quite tricky for the registration process in areas like that. Do you always scan at scale 1? Kirk has asked. When using the scanner for topo work, are you drafting the data in CAD, then assigning heights, using software and assigning heights to the polyline as it's drawn? So generally, Kirk, the points are in their XYZ coordinate. So we'd have them, we'd draw it in 3D, and then if the client wants, we'd flatten out the Z values to produce a 2D deliverable. Chris asked, I use scanners a lot, but not for building surveys. What's the best practice to control the scans inside a building, such as the hospital or a culvert, to align correctly? Did you also traverse through the building with a total station? No, Chris, we traversed outside for the control network, and then we had our additional control points there. Sometimes you would need to traverse through a large building and have the control, but not always. Roy has asked, RE rail surveys. With laser scanning, we had issues with the laser skimming the shinny worn areas for the rail for positioning. Do you incorporate a rail shoe for accuracy or use the software app? Yes, Roy, a lot of times when we work on the tracks, we'll use the rail shoe so that we have the exact measurement, because it can be quite difficult to see the scan, particularly if you're zigzagging and you have one face of the rail from the outside and the other side from the inside. It can be quite tricky. Brian asked, we're testing mobile scanning data against band C data collected traditionally. I believe band D is not possible with mobile mapping. What is your experience and what do you believe is achievable? That's a very good question, Brian. When mobile mapping kind of was first being touted, we had looked at it, and with our control points, the tests that were done at the time, we couldn't guarantee kind of centimeter accuracy, so we stayed away from it then. Generally, mobile mapping, the accuracy is determined by how good your control network is. So if you traverse and maybe do a precise leveling run on top of that for your control network and it's spaced accordingly, you should be able to achieve band D with the mobile mapper. Susie asked, for the closed loop traverse, you start with known points measuring by GLSS or T-gate technique. Yes, we install our own control network and then we'd adjust the traverse afterwards. So, in the field, it's open, but when it gets back to the office, it's processed and closed. I think that's it, unless anyone else has any questions. I wasn't expecting so many questions, thanks.
No, it's great to see that it's generated a lot of interest and kind of resonates with people. It's nice to see this kind of...
bear with me a second, Ronan. Ivan has asked, how would you quality assure the deliverables when they're requested into GCS geographic coordinate systems? Ivan, that is tricky. Usually we would produce the cloud in the ITM 2015 coordinates, but there are legacy projects which might be running, before that in the old Irish National Grid. So generally we would draft the drawings in ITM and then do a conversion afterwards, rather than creating two separate clouds in different coordinate systems and doubling up the drafting.
Anybody have any other questions? No, fantastic. But no, it was great to see the kind of high quality deliverables that you guys are churning out. Some really interesting range of projects that have been involved on. The presentation will be available on YouTube to download and watch there at a later date. And I'd like to thank Draiochta and Apex Surveys for taking some time out of their day to kind of share with us the type of projects that they're involved in, and we look forward to future and see what other stuff they get involved in. So thanks everybody for their time, and we hope to see you again.
And just in case I missed anyone's questions there, apologies, please feel free to reach out to me. Just info@apexsurveys.ie, it'll get to me. And yeah, any queries whatsoever, happy to discuss kind of offline in greater detail.
Brilliant. And thanks to Heather for facilitating us today as well.
Lovely.
Great stuff. Thanks, everyone.
Thanks, Ronan. Take care. Bye-bye.